All right, we're on the back side of day 5 notes, and in number 3 it says find the volume to the nearest hundredth of the composite solid shown in the diagram below. And so this composite solid is made up of a pyramid on top and a rectangular prism or a box on the bottom. Okay? And so very similar to what we had in our warm-up, we're going to go ahead and in order to find the volume of the total composite shown, we're going to go ahead and say volume of a pyramid plus the volume of a prism, and that's going to give us the total because we're adding them together. Okay? We're going to go ahead and fill in our formulas. So the volume of a pyramid is 1/3 big B times H plus the volume of the prism, which we could either do big B times H or we could do length times width times height. It is completely up to us. So we'll do big B times H just because we're already doing big B for the pyramid, and they have the same base in the pyramid as the box does. So we'll be able to sub in the same thing for big B. All right, so we're going to go ahead and keep the 1/3. That big B will take off to the side, and we'll say big B equals area of the base. And in that pyramid, this is the base of it, okay, which is a square. Okay? And we could tell that it's a square because it's the same base shape in the prism, and it's 7 by 7. So area of a square or a rectangle is base times height, which is going to be 7 times 7, which is 49. And now we can take that 49 and go back and replace that big B with 49. Okay. Times the height of the pyramid, and you guys can see in the pyramid, the height of it is measuring with that 10, so the 10 will go in. Okay. And we can go ahead and type that in before we go to the volume of the prism. So in our calculator, we're going to type in 1/3 times 49 times 10. And when we hit enter, we're going to end up with 163.3 repeating. Okay. And now we're going to go ahead and go to the volume of the prism and add that on. So the prism is also big B times H, but because the big B of the pyramid is the same as the big B of the prism, we can go ahead and insert the same 49 that we got for the pyramid. Okay? And then multiply by the height of the prism, which you guys can see that this 15 is measuring the height. And we're going to go ahead and type that in. 49 times 15 for the volume of the prism is 735. And now when we add the two together, we get 898.3 repeating. Okay. And they're going to ask us to round to the nearest hundredth. Okay. So I'm going to do one thing. I'm going to rake this a couple more 3s so that I can look at the second 3, which is the 100th, look next door at another 3, and it's not going to move it. And so we're going to finally say that the volume of our composite solid here is 898.33 units cubed. All right, so we'll put it up here. Volume equals 898.33 units cubed. And there's the volume of our solid. Okay. All right, guys, let's go ahead and take a look at number 4. No picture drawn, so it says the base of a pyramid is a rectangle. So this is the first pyramid that has a different shaped base. All the other ones so far have had a square, but this one has a rectangle. So I'm going to draw a rectangle. It almost looks like a parallelogram just to give it a 3-dimensional effect. I'm going to put a dot in the middle of the rectangle and then a dot right above it. Okay? And then I'm going to go ahead and connect that dot to the 4 corners of my rectangle here. And so it kind of looks like a pyramid there. All right. It says that the base of the pyramid is a rectangle with a width of 6 and a length of 8. So in my rectangle, we got a 6 by 8 rectangle. They want you to find in centimeters the height of the pyramid. And that's my height. Okay? And they're telling us the volume is 288 centimeters cubed. All right, so this is a work backwards one. But because it does deal with the volume of a pyramid, we go to our formula sheet. We write down V equals 1/3 big B times H. We take that big B off to the side, and we say big B equals the area of the base. And in this case, our base is a rectangle, so it's still base times height. It's just that the dimensions are the same. One's 6 and one's 8, whereas a square, they're going to be the same number. Okay? And 6 times 8 is 48, and now I can take that 48 back to big B and replace big B with 48. Don't forget to bring down your 1/3. And this is a working backwards one, so the volumes get replaced with what they told us, which is 288 times our height. In our calculator, we're going to type in 1/3 times 48. So we end up with 288 is equal to 16h. We're going to divide by 16. And h is going to come out to equal 18. And that would be centimeters. And it's just centimeters because it's just the height. It's not a volume or an area. Okay, good, guys. Let's take a look at 5. In 5, it says find the volume of the pyramid that has a square base with edges of 18 feet and a slant height of 15 feet. And as soon as you got that slant height in there, we know that we can't handle that or deal with that 15, okay? So we're going to make that 15 the hypotenuse of a right triangle by drawing the height in straight down and then going halfway across the square on the bottom. And because it's halfway across the square on the bottom there, that bottom of that right triangle that we see here is 9. Okay, and so we're going to do a little Pythagorean theorem in order to solve for my height, so I can use the height and not the slant height. The slant height's too long to be the height. Just remember the slant height is always going to be the hypotenuse, so always going to be C in our Pythagorean theorem. And remember, we only went halfway across the bottom there in our right triangle, and so that's going to be 9. 9 squared is 81. 15 squared is 225. We're going to take away the 81 from 225, so we have b squared equals 144, and therefore b equals 12. And now we're going to go back and label our height as 12 and cross off the slant height so we're not tempted to use that 15. Okay. All right, since we're dealing with volume of the pyramid, we're going to write volume equals 1/3 big B times h. We're going to take that big B off to the side. And remember that big B is the area of the base. And we're back to it being a square. Still base times height, though. It's just that the base and the height are the same, so 18 times 18. And 18 times 18 is 324. And now I could take that 324 and replace my big B with it. And so my volume ends up being 1/3 times 324 for the area of my base times the 12 I found for the height by doing the Pythagorean theorem. Okay? All I have to do is type that in, 1/3 times 324 times 12, hit enter, and I end up with 1,296, and we're in feet cubed because it's a volume. And there we go. All right. Don't forget we have to talk about cross sections with each of our solids. And so cross sections is the face you get when you slice a solid figure. Cross sections can be slices that are horizontal, vertical, or diagonal. And a cross section that is parallel to the base of a pyramid. Let's see what happens when we do that. So here's the base of my pyramid. If I slice it, okay, it's parallel to that base. It's a nice horizontal slice. And if I think about the shape that I would get, all right, it would be the same shape that's on the bottom, but smaller. Okay, so like for instance, there's my base, and my shape that I get right above it is the same shape, just a different size. And therefore, that cross section that's parallel to the base of my pyramid will be similar because it's not the same size, okay, to the base. Okay, but it'll be the same shape. So for instance, this would be a smaller version of what is on the bottom of my square pyramid here. And therefore, that would also be a square. Since this is a square pyramid, it would just be a smaller square. Okay. All right, if we think about slicing it straight down in what we call the apex is the tippy top of the pyramid. So if I line up my knife right here and I slice downward, you guys can see that I would get a triangle. Okay, now if I slice my pyramid, okay, and we saw this in that video that we watched with the Slice Master, if you slice it not through the apex, okay, but you slice it, down here, you line up your knife here and you slice it straight down, okay, you're cutting the top off of that triangle and you end up with a trapezoid. Oop. All right, same thing happens if you slice at an angle or a diagonal slice as well. Okay. All right, so just answering the last question here, it says the two-dimensional cross-section that's taken of a three-dimensional object. If this cross-section is a triangle, What cannot be the three-dimensional object? Okay, so this one's a little bit different. So they're basically saying that you can get cross-sections that are triangles in 3 of our solids. And with a cone, you can 100% get a triangle. If you slice it perpendicular to the base there, you guys can even see that there's a triangle in a cone. So a cone is possible. All right. Our cylinder, if you can think about how to slice a cylinder to get a triangle, I can't. So I'm going to hold off on that one. I might think that's the answer. All right. If we take a pyramid, we just talked about it. But if you go straight down from the apex of a pyramid, you guys can see that a pyramid has triangle shape in it. So a pyramid is possible. And our last one, a rectangular prism. And this one's a little bit hard to see. But if I draw a rectangular prism real quick and I slice just the corner of it off, I don't know if you guys can see that. That would make a triangle there. When I pull this part of that prism off, that would be a triangle. That was a little bit tough to see, but yeah, a triangle is not possible from a cylinder. With a cylinder, you can get a circle. If you go horizontal, you can get a rectangle. If you go vertical, you can get an ellipse if you go at a diagonal, or you can get a parabola if you go at a diagonal to the base. Okay, but notice that there's no triangle in a cylinder. All right, hopefully that helps, guys, and I'll see you guys on the last day of notes in this unit, and we'll do the sphere.